In this video, we'll have a look at adding and subtracting surds. In my first expression, I can see 3 root 6 plus 17 root 6 minus 2 root 6. I can see that all of those three surds are already written in simplest form and they're all like surds. So we can go ahead and add and subtract those surds. So we add the numbers in the front of the surds, 3 plus 17 minus 2, and that will tell us how many lots of root 6 we have. So that is equal to 3 plus 17 minus 2 lots of root 6. And we simplify that, and that gives us 18 lots of root 6. In our second expression to simplify, I can see 5 root 3 and minus 5 root 2 are already written in simplest form, but 2 root 12 and 3 root 8 are not. So we need to write them in simplest form before we can add and subtract our surds. So we keep 5 root 3 as it was, plus 2. Now we know we need to write square root of 12 as a product of its factors, where one of those factors is a square number. So the factors that make up 12, we have 2 and 6, but neither of those is a square number. We have 4 and 3, and 4 is a square number. That's in our list down the side here. So we can rewrite square root of 12 as square root of 4 times 3. Then we have minus 5 root 2, which stays as it is. It's already simplified, plus 3, and we need to write square root 8, once again, as a product of its factors, where one of those factors is a square number. And we can write that as 4, which is a square number, times 2. Then we go through and we simplify. So 5 root 3 stays as it is, plus 2. Now our square root 4, we know that's equal to 2. So we can write that as 2. It comes out of the square root and becomes 2, times, and the square root 3, the 3 stays under the square root. Then we have minus 5 root 2, plus 3 times our 4, square root of 4 will simplify to 2, times by square root 2. And so we go through and simplify a little bit more. We have 5 root 3 plus 4 root 3 minus 5 root 2 plus 2 3s are 6 root 2. Now all of our surds are simplified and we can see some more like surds there. 5 root 3 and 4 root 3 and minus 5 root 2 plus 6 root 2. So we collect our like surds. We'll do the square root 3's first. And we have 5 plus 4, which gives us 9 square root of 3. And we have minus 5 root 2 plus 6 root 2. Minus 5 plus 6 is going to give us 1 root 2, or just plus root 2. We don't need to write the 1. That simplifies down to 9 root 3 plus square root of 2. Our final example is a little bit trickier because it's an algebraic example, but the process is just the same. So let's start at the beginning. We keep our 1/2, and we want to write 100 times a cubed times b squared in square factors. So 100 is already a square number. I can see that on my list over on the right hand side. It's 10 times 10. So we keep the 100 factor, times. Then we have a cubed. That's not a square term right now, but we can write it as a squared times a. Make our square root a little bit longer. And then we have times b squared, which is already a square term. So that's our first term. Then we take our second term, plus ab, square root of 36a. Now I can see 36, that's a square number already. 6 6 is 36, times by a, which doesn't have a square factor. And then we have minus 5, square root of 4. We know 4 is already a square number. We can see it in our list. That's 2 times 2. So we have 4 times a squared is a square term already, times b. So we've written them as their factors. And let's go through and see which ones we can simplify. So we keep our half, times by 100 is under the square root. So to bring it out of the square root, we take its square root, which is 10, times a squared. We know square and square root are inverse of each other, so they undo one another. And we have a. This a is going to have to stay under the square root because it's not a square term. It can't come out. So times by square root of a, times by another b squared is under the square root, so that can come out and become a b. Plus ab times 36 is a square number, so the square root of 36 is 6, times, and the a has to stay under the square root because it's not a squared term, minus 5 times square root of 4 is 2, times the square root of a squared is a, times by the square root of b has to stay under the square root because it's not a squared term. Let's go through and simplify. We have half times 10, which is 5, times a times this b on the end. 5ab square root a plus 6ab square root of a minus 5 times 2 is 10 times a, 10a square root of b. Now that we're all simplified, we can look for our like surds. I can see a square root a surd here and a square root a surd here, so they are like surds. We have 5ab plus 6ab. So 5ab's plus 6ab's gives us 11ab square root a minus 10a square root b. And because they're not like surds, we have a under this surd and b under this surd. That's as simplified as we can go. So there you have it.